computer system has multiple users and allows the concurrent execution of multi-processes, then access to data must be regulated. For that purpose, mechanisms ensure that files, memory segments, CPU, and other resources can be operated on by only those processes that have gained proper authorization from the operating system. For example, memory addressing hardware ensures that a process can execute only within its own address space. The timer ensures that no process can gain control of the CPU without eventually relinquishing control. Device control registers are not accessible to users, so the integrity of the various peripheral devices is protected. Protection, then, is any mechanism for controlling the access of processes or users to the resources defined by a computer system. This mechanism must provide means to specify the controls to be imposed and to enforce the controls. Protection can improve reliability by detecting latent errors at the interface between component subsystems. Early detection of interface errors can often prevent contamination of a healthy subsystem by other subsystem that is malfunctioning. Furthermore, an unprotected resource cannot be defined against use by an unauthorized or incompetent user. A system can have adequate protection but still be prone to failure and allow inappropriate access. For example, a user whose authentication information is stolen, her data could be copied or deleted, even though file and memory protection are working. It is the job of security to define the system from external and internal attacks. Such attacks spread across a huge range and include viruses and worms. Denial-of-service attacks, identity theft, and theft of service. Prevention of some of these attacks is considered an operating system function on some systems, while other systems leave it to policy or additional software. Due to the alarming rise in security incidents, operating system security features represent a fast-growing area of research and implementation. Protection and security require the system to be able to distinguish among its users. Most operating systems maintain a list of usernames and associated user identifiers. In Windows parlance, this is a security ID. These numerical IDs are unique, one per user. When a user logs into the system, the authentication stage determines the appropriate user ID for the user. That user ID is associated with all of the user's processes and threads. When an ID needs to be readable by a user, it is translated back to the user